Welcome to lesson 49, graphing linear inequalities. We're going to take a step away from graphing functions and equations and learn how to work with inequalities. So that means expressing the inequality in slope-intercept form. Form is going to look exactly the same. It's just going to either be, instead of y equals, it's either going to be y is less than or y is greater than mx plus b, or less than or equal to or greater than or equal to mx plus b. Second thing we're going to do is graph the inequality. We're going to learn how to do that with our calculator as well as plot the points, and then accurately represent the inequality on the graph, because we do have to transfer the inequality from our graphing calculators onto our graph paper. And there are two important questions we're going to ask ourselves. Is the line going to be a dashed or a solid? Here's a little hint. It has to do with whether or not it is less than or equal to. And am I shading above or below the line? Okay, I've highlighted some of the key points from your notes. High level, linear inequalities replace the equal sign. They are not equations. They will have a y, since I'm doing slope-intercept form, y is less than or greater than or less than or equal to or greater to some expression. And the solution is any ordered pair that makes the entire inequality true. So first thing we're going to look for on our graph is we're going to shade the region of the graph. We're going to shade the part of the graph that has the solution set. And what does that look like? I decided to just graph a really simple line, y equals x. So that's what I've graphed here, y equals x. And I'm going to show you what it looks like when y is less than x and y is greater than x. First thing is, because these are just less than or greater than symbols, we cannot have solid lines. We would have a dashed line. So I'm going to use my eraser and turn this into a dashed line. This means that my answer, my solution, cannot be on this line at all. My solution would not be included here. Now, in this first part, it says y is less than x. So this means my solution would be below this line. So anything down here, all these points, count as a solution. If y is greater than x, then I would shade above the line. Okay, so that's the first kicker, and that's why we like having it in y-intercept form, so that I can see am I shading above or below. So those are the first key points. If it is just a regular less than or greater than, then this has to be dashed. The line has to be dashed. And then if it's less than, I shade below. If it's greater than, I shade above. So what does the solution set look like when I have the greater than or equal to symbol? Like when our inequality symbol is underlined, that means it can be equal to, meaning that these are all possible solutions. That is why I can have a solid line, because as long as this is underlined, this line can be solid. All right, and I'm going to use the same rule as before. When y is less than, I shade below the line. And that means my answer is anything on the line or below it. And if y is greater than, then I just shade above. And that's it. So that's all you're looking for in this problem. You're looking for, first, is my inequality symbol underlined? Because that's going to tell you if it's solid or dashed. And then is y less than or greater than? So am I going up, below, or above? I'm going to do this first example as if I did not have a graphing calculator, so you can see what steps you could use. So I'm going to take my equation and I'm going to rewrite it in slope-intercept form. Okay, now Let's imagine for a second that this was an equation. If we were to graph y equals negative 2x plus 4, the first point that we can graph would be 0, 4. So we're going to do that. So here's point 0, 4. Let's also use this equation to figure out what if x was 0. So 0 is equal to negative 2x plus 4, and we would just solve it. And we would get 2 is equal to x, or 2, 0. And that's really all we want in the beginning. We just want 2 points. So we can graph our line as if we were graphing a line. So first question is, looking at this equation, which I'm going to write here, what do we know? Is it going to be dashed or solid? Because this is not underlined, it's going to be dashed. There we go. So I kind of made a dashed line. It's not perfect. That's kind of why what I like usually do to use a straight edge. And I like to go through the points and make the line, and then use my eraser to dash it. Okay, so it's a dashed line. So second question, am I shading above or below? So because this is saying y, and I'm going to put this here, y is less than, then I'm going to shade below. So let's get our shading, and there we go. So this represents my solution set. It's all the values that are below this line. All right, hit pause and jot this down into your notes. And that's it for today's lesson. I'll see you in the next one. Be well.